Welcome everyone, and thank you for attending today's Healthcare IT News webinar, How to Scale Healthcare Analytics Applications Securely in the Cloud, sponsored by ClearDATA. My name is Mike Milliard. I'm the editor of Healthcare IT News, and I will act as the moderator today. We look forward to your questions and comments, which you can submit at any time by accessing the question box on your screen, and we will make every effort to answer your questions during the presentation's live Q&A at the end of the session. Today, we'll learn how healthcare providers have been able to support the growing demands of big data applications that support population health initiatives using a scalable cloud architecture. This webinar will show you the steps that are working to provide healthcare analytics teams with a responsive performance in a secure environment. Our speaker for today's webinar is Chris Bowen. Chris is the founder and Chief Privacy and Security Officer at ClearDATA. And so without further ado, Chris, please begin the presentation.
Thank you, Mike. I appreciate it. I appreciate the time that you're investing this morning to learn a little bit more about how we see the ability to scale analytics platforms in the cloud. In order to really provide a baseline for that, we're going to go over a couple of things. You're going to see us talk a little bit about the cloud reference model, as well as the cloud service model and deployment models. Those have a direct impact on how you want to deploy your analytics workloads. We'll discuss some scalability concepts, as well as get into one of my favorite topics, which is data usability, as well as data privacy. And then we'll do a quick overview of a couple of analytics platforms as well. Next slide, please. So, analytics is really an amazing set of sciences and tools, and it's almost an art form as well. And as you can all imagine, there's some amazing insights that you can provide, even if you don't know that you could potentially get an outcome of a certain piece of data. So let me start this presentation by telling you a story. I like to liken all of these healthcare solutions to real people. So my story today is about John. Now, this is not his real name, but the facts that I'm going to share with you are real. John is 42 years old. He's from New Jersey. Last year, John showed up in an emergency room following a seizure. The doctors treating John weren't sure whether to perform a particular procedure or not because of the condition that John was in. If they provided the procedure, potentially could have killed him. If they didn't, it potentially could have killed him as well. And a little bit more detail, if we go to the next slide. When he was admitted at Our Lady of Lourdes Medical Center in Camden, the clinical team had noticed that he had an atrial fibrillation, which is really an irregular and fast heartbeat. They weren't sure, however, if it was a chronic condition or if the seizure had triggered this anomaly in John's heartbeat. The seizure, by the way, had happened 20 minutes before he arrived at the hospital. So this detail is really important because it would help determine whether or not the medical staff could electronically stimulate the heart to get back to its normal rhythm. If it was chronic, however, the cardioversion could have dislodged an appendage clot, which could have sent that clot to the aorta and possibly triggered a stroke. However, failure to treat that arrhythmia could also result in a stroke and possibly death. So kind of a very tenuous situation in that ER. Next slide, please. So I want to talk to you a little bit about, before we talk about the conclusion of John's treatment, I want to talk to you about a hospital that I think has done some amazing work in the analytics space. Geisinger, many of you are familiar with Geisinger out of Pennsylvania. They, a year or so ago, they created what's called this unified data architecture, which allows them to integrate big data to their existing data analytics and systems. It uses their capabilities to track and analyze patient outcomes, to correlate their genomic sequences with their clinical care, for example. It helps them to visualize healthcare data across cohorts of patients and networks of providers. And so Geisinger's UDA, as they call it, is really one of the largest practical applications of point-of-care big data in healthcare. For example, they have thousands of CPUs processing and delivering hundreds of terabytes of data every single hour. It's a pretty fascinating system. And at Geisinger, clinicians since the mid-90s have been entering data into EMR and EHR, which is great, but we all know in healthcare sometimes that data gets siloed. It's not as useful because it's just a snapshot of one particular slice of a person's life. So at Geisinger, what they've learned and what all of us know is that people leave breadcrumbs of data everywhere they go. So Geisinger pulls in not only details about their health, but can pull in details from their grocery store purchases and loyalty programs and smartphones and apps and all kinds of things related to that person's life. And these things can tell you a lot about the person's health and potential indicators for health challenges. So in the next slide, if we look at that, Geisinger has a great approach. However, there are some challenges to doing this. One thing that we've seen is there's a shortage of data scientists. There's the ability or the challenge related to architecting your applications to scale in a way that actually works. So again, it's not merely the accumulation of vast amounts of information, but really it's a collection of interconnected and interrelated data points that when you analyze it carefully can give you a much better picture. Obviously, privacy and security concerns are a challenge sometimes. Sometimes the correlation of the data does not equal the causation of the problem. And of course, infrastructure and compute can be solved by a lot of different solutions that we're going to talk a little bit about today. Next slide, please. So again, at a high level, analytics and implementation challenges include interoperability. There's some skills gaps. There's compliance and security. On the next slide, how you deploy your information, your analytics solutions is really dependent also on the cloud model that you choose. So the cloud can really be a critical component to help you solve the challenge with analytics. Really, there's 4 different types of models for cloud deployment. There's the private cloud, which is what you would typically see in a hospital or a company's downstairs data center. Sometimes you'll see a community cloud where like-minded organizations will band together and create their own private cloud, but they'll share it among themselves. There's the hybrid cloud, which is what you see quite a bit around typical healthcare applications. And what we're seeing more and more of is that the public cloud is becoming a much better way to deploy analytics platforms and solutions as well. But that's really using an Amazon, an Azure, a Google, those kinds of cloud environments. Next slide, please. So again, the public cloud can actually help modernize the infrastructure. It can help you consolidate and centralize your data environments. It can actually help you ensure that you have privacy and security challenges addressed. We'll explain a little bit more about that in a few slides. Next slide. Going to the cloud reference model in slide 13, this model is really referred to by NIST and many other government organizations, but the cloud reference model talks about how security and privacy fits into the reference model for cloud. For example, you need to be able to have the controls to ensure that your analytics workloads are not violating patient or individual consents, for example. You need to make sure you have your security aligned to the workload and make sure that your privacy officials are involved in helping to ensure the privacy of individuals. At the bottom of the cloud reference model is certainly your physical resources, your hardware, your facility, your virtualization layers, and then you have in the middle of that model the service layers. We're going to talk a little bit more about those service layers because those also have a direct impact on how you deploy your environments. And then of course your services management and security and privacy overlays the whole thing. So going back down to slide 20, if we are going to talk about the cloud service models at a high level, you really have 3. You've got the infrastructure as a service, you've got the platform as a service, And then you've got the SaaS, the software as a service model. So, just talking high level of the IaaS model, the infrastructure as a service model, this is really where you can start to deploy workloads and have control of operating systems and some of the lower layers. As you climb the stack, you have control of the middleware perspective of that. And then from a SaaS perspective, and we'll see more about this in a few moments, you have very limited visibility into what's underlying your data presentation. So on slide 21, if we talk about SaaS characteristics, and if you think about analytics workloads, there are those providers in the marketplace that provide a SaaS solution for analytics. The characteristics of a SaaS model is really a hosted application management. You've got software on demand. You can access your data from a presentation perspective anywhere. And there's a lot of benefits to this. There's the ease of use. You don't have to do a lot of things in terms of maintaining your OS or your infrastructure. So those are some good things. Now, if you trust your vendor or your provider and trust that they are protecting the data underlying, then great. But there are certainly some diligence requirements that need to be done when you choose this model. So from a SaaS perspective, customers of a SaaS model, they can use the application, they can access the application, but they cannot manage or control the underlying infrastructure. Let's talk about platform as a service for a moment. The characteristics of platform as a service really allow you to have multiple languages and frameworks within a platform. You can code different applications that use the platform. It provides flexibility. This is an important one. It allows choice to help you reduce vendor lock-in, for example, and it gives you the ability to auto-scale. One of the benefits here is that the OS can be changed. It can be upgraded frequently. You can globally distribute your environments. Costs are usually a lot less here. Next slide. Now, one of the things you cannot do from a platform as a service model is manage or control the underlying infrastructure, but you can deploy your applications usually pretty well. Going now to the infrastructure as a service model, the characteristics of this model help you to support scale. It helps to, it allows you to do self-service on-demand capacity. You can architect high reliability and resilience, and some of those benefits, some might see these as benefits, others might see these as a challenge, but your operating system can be visible to you. You can actually see everything about your environment. Again, the customer in the IaaS model, they cannot manage or control the underlying physical infrastructure, for example, or the underlying hypervisor layers, but they certainly can provision storage and networks and other resources. They can control the OS, control the networking, etc. So going now to slide 27, deployment models. Seen a different way, if you look at this chart on slide 28, this table really helps us understand what kinds of information are available given a service model. So if you look at the far right, if you have everything in-house, obviously you have visibility to everything. There's a trade-off for that, though, and that's a lot of cost. Potentially you can't do a lot of things from a scalability perspective. Climbing up that stack a little bit to the left column of IaaS, from that model you have a lot more visibility than you do with PaaS or SaaS, but you still don't have necessarily the control of the networking storage and some of that virtualization. But you can certainly control a lot of the other stuff. And then the visibility to the infrastructure and the environment becomes less and less up that stack. So resulting in the SaaS model where really all you have to control is the application access and some ways of laying out and visualizing your data. So going to slide 29, if you think about that IaaS model and you think, wow, it would be great to scale that, but I just don't want to have to worry about deploying OS patches and worry about vulnerability management on those operating systems, et cetera. A managed service model can take a lot of that burden from you and give you the benefits of the IaaS model. So for example, ClearDATA would offer something like this as well, where not only is the compute storage database and networking taken care of, but same with the encryption, the network, operating systems, vulnerability management, and platform as well. So there's various models in the marketplace. If you want to get into analytics and start to deploy your analytic models, these are some of the things that you should consider before you wholeheartedly jump out and do that. Going to slide 30, for example, if you see the need to scale, let's talk a little bit about some of the scalability concepts that are involved in these analytics workload discussions. If you are in genomics, for example, if you are like Geisinger, if you refer back to that slide where they actually mash up and analyze the genomics mappings with clinical data, you can see the need for a massive amount of burstability in terms of compute and storage and memory in terms of how to efficiently crunch that data. So how do you scale? Well, a couple of concepts. You can scale vertically, or you can scale horizontally. And I'll really focus my efforts on this next section of this dialogue with the public cloud. So from a vertical scale perspective, what this really means is that you would increase the specs or the specifications of an individual resource. So I'll show you a model in a few minutes, an SAP HANA model that embraces this type of scaling model. The cons to this are that eventually your limits can be hit. Sometimes it's not always cost effective, and sometimes it's not always highly available. The horizontal scaling strategy, if you think about that accordion model, where you just expand outward, you're really just increasing the number of resources that you're bringing to bear in that model. So for example, you're adding more hard drives, maybe you're adding more storage or servers to support an application. This is usually enabled if you use stateless applications which don't rely on information from or dependencies from other systems as you need to scale. It thrives on distributed processing. So if you think about distributed processing and you think about highly available systems and you look at an Amazon set of regions, for example, and availability zones, scaling out to different zones can also help you with high availability. Bootstrapping really is the act of deploying servers, deploying many servers in some cases. In some cases, customers will use an entire data center at Amazon over a weekend to generate some research data. And so being able to scale that and not necessarily use all of one single data center, but spread that across multiple data centers would be a much better way to go. If you want to talk scaling horizontally as well, containers can really help you do that. If we go to the next slide where we talk about virtualization versus containers, really what we're seeing is that eventually hosting data on virtual machines, hosting applications on virtual machines will become a thing of the past as virtualization climbs up into the container level where you can deploy massive amounts of applications, very single-purposed applications, quickly across multiple environments in a way that's not dependent upon a virtualization, a virtual machine with an OS attached to it, for example. So there's a lot of great things that can happen with containers in this type of deployment model as well. So going now to slide 32, if we talk about security and automation objectives, really you want to make sure that when you're deploying your analytics model, you want to have a strong and secure audit trail. You want to make sure that you can maintain that audit trail from the very beginning of the instance that you create, all the way through the end of that life cycle. You want to make sure that you have coupled or decoupled your tools, your orchestration tools from your application. So, for example, if I'm deploying an application, I want to do so without the need to have a whole bunch of other applications that have to boot up in a specific sequence. I can do that with containers and microservices. I want to make sure that I can have highly automated systems. When I select the tools to join with my systems to keep it protected, to keep it secure, or being able to monitor that, I want to make sure that I don't have to have a human body register those tools on every virtual machine that is spun up, simply because the human cannot keep up with that. And then, of course, I want to make sure that we have some services that we can rely on. Maybe those are external services from a managed provider. Maybe you're doing it all on your own in-house, but you want to be able to have support when you need it. So if we think back about the scalability concepts, this is a diagram of an SAP HANA model, which you can find on the internet on the AWS website. The scalability of this environment is a vertical scale. So it's one HANA cluster where they are scaling. If you see those three data volumes, that's really where it scales. The SAP HANA can use up to, I think Amazon now has an X1 16x large, which is a machine that has 1.9 terabytes of RAM and 128 CPUs, which is a massive amount of compute. But as I mentioned earlier, sometimes these scalability models can hit their limits. So again, this is a single node deployment. They're using an EC2 instance with Amazon Elastic Block Storage, EBS, and that's really how they've architected that. It's a fine architecture. It's a vertical scale model. If you look at ClearDATA, which is a Hadoop distribution, they use more of a horizontal scaling model. This model allows them to distribute scale across multiple availability zones in that accordion style model. They use a private subnet cluster topology, which launches the cluster launcher instance, which is in the public subnet. They have elastic IPs that are assigned to the instances, and of course, security groups that allow SSH access to the instance that's created. And so all other Hadoop-related EC2 instances in this model would be created in the private subnet. And so just another different topology. Going now to slide number 36, we're going to talk a little bit more about the data usability versus privacy model. So in this model, we talk about the need to have access to data, but you still have that concern, that challenge that's related to privacy. And so in order to do this, you need to have privacy by design and security by design fit into your solution. How do they both fit? Well, a little bit more on the topic in slide 37. Certainly they can fit by using patient consents or consumer consents. Contextual notices are very important. So if you think about contextual notice in the applications that you're using to get consents, maybe I'm a patient signing up for a clinical trial, and I want to allow you to use my data. As I click on a research trial, maybe I'm giving you another ability to consent to having that data used in a different way, or maybe expanding my consent from the previous consent. Or if it's a particularly specific use case, perhaps that consent needs to be tightened down. But having contextual notice can certainly help that patient or that user experience, and it can also help your ability to capture those consents. In those consents, of course, sharing the benefit, conducting your privacy impact assessments are very important. Going to slide 38, when we talk about privacy by design, there's really 7 principles that envelop privacy by design. The first one really should be, you should be proactive, not reactive in getting those consents. So preventative, not remedial, if you want to use a fancier term. So this would anticipate and prevent the privacy invasive events before they happen. So again, turning on cookies, if you go to Europe ever, you'll see that the European Union requires that you're notified that cookies are enabled. They're forewarning you that they were tracking some information. So they're being proactive in that case. You know, in an analytics workload and an analytics model, you want to take the same approach and be proactive. Privacy should be the default setting. So if you look at the settings for consents, if an individual does nothing, their privacy should still remain intact. And no real action is required on the part of the individual to protect their privacy. Opting in is a much better way to engage a customer or patient than requiring them to opt out of everything from a privacy perspective. Privacy should be embedded into the design of the application. So again, if you're gleaning data from a Fitbit, for example, you should understand what you're sharing. You should, if you're the maker of Fitbit, you should be able to share with the user how this data might be used and shared, and give you the opportunity to opt into that. But it should really be embedded into the design and the architecture of the systems that support it. If you think about cross-border data transfers, you want to make sure that you set up your systems, your underlying systems, to support and reinforce the fact that perhaps if I'm doing business in China, I can't let that data move out of China, for example, or if I'm hosting data in Germany, I can't let that data move outside of those borders either. So you have to have those kinds of considerations before you start to architect your solution. The next principle is really, let's be, in principle 5, be fully functional. Let's have a win-win. Let's make sure that the patient or the individual can see the benefit of participating in the system. We want to be visible. We want to keep it open. So be transparent about how you are allowing people to use your system and how you are sharing their data for the betterment of them. And then finally, having respect for the user. So just because you have a treasure trove of data doesn't mean you can mash it up into a Hadoop cluster and start to have outcomes. You actually need to consider, from a privacy perspective, how you need to assess that and how those consents can work. So going to control transparency, keeping it open, one of the things we like to do is make sure that the customer has visibility into the controls related to the system. So in an infrastructure as a service model that we talked about earlier, having transparency to know that, hey, my volumes are encrypted, and here's my check or my audit on that system to tell me that, is a very important point. And so if we go to slide number 42, for example, and we are using HIPAA as a framework for controls, one of the things you want to have is access to your logs, but you want them separated. You want to separate those from your environment. You want them protected, and you want to be able to know if the logs are flowing. And so you want to have indicators and visualization to that effect. You want to make sure that your overall compliance is tracked and it's auditable, and that if you need to make adjustments because perhaps a backup failed, that you can go in and make sure that it's taken care of, for example. So whatever types of systems you are deploying, you want to make sure that you are aware of the system compliance checks that need to happen. So slide 43, if we talk about global considerations, we've touched on it shortly. In the global world, there are different regulations for different geographies. Before you start to do business in a different geography, consider what type of regulations you need to comply with. Do you need to comply with GDPR? If you're in Europe, well, by next year you'll have to. Or if you're moving into Australia or China, you need to be aware of what those regulations are from a privacy perspective. You need to consider where the location of the infrastructure is, as well as the latency considerations for some of the critical apps. for applications that you're trying to run. So it's easy to deploy an application, very easy to deploy an application. It's a little harder to architect the application infrastructure to respect those borders and respect the privacy that's required inside those borders. But those are some very important things to consider. Going to slide number 45, one of our objectives here was to share with you some of the platforms that are used today in healthcare. There's a lot of them. A lot of them I haven't noted here, but there's quite a few that are really, really good. For example, White Cloud provides healthcare performance management technology, which allows physicians to help offset some of the financial risk-bearing challenges faced with patients leaving networks and things like that. Reinforced Care, for example, it does provide an analytics platform that does proactive patient follow-up, real-time alerts and things like understanding where they're at. So certain geolocation features can be enabled to say, okay, you need to check into this facility if a certain date has passed and you're crossing nearby. So there's just all kinds of ways to monitor as well as notify the customer. SAP HANA, we've talked a little bit about their architecture, but in this case they use advanced data processing for all kinds of data, whether it's text or spatial data or graphical data. So they'll allow you to provide your own systems with great insights, deeper insights on using machine learning and predictive analytics capabilities. And of course, we talked about Cloudera, which is a Hadoop distribution, lots of the same features. Mongo is another one that is the underlying infrastructure, the architecture for storing data in flexible JSON type of documents. So fields can be anything from a document to a data structure, and they can change over time. So really a NoSQL type of deployment, making it very easy to work with different data types. So let's go back to our story, slide 46. So it all makes sense to me now that if I look at all of these analytics platforms and there's a way to measure what's going on. If we go back to John, as the medical staff was weighing the pros and the cons of resetting John's heart rhythm, one of the caregivers actually noticed something. John was actually wearing a Fitbit, and he had a smartphone with him as well. And so the conscientious medical staff looked at the smartphone, they pulled it up, and the data from the Fitbit was synchronized, and it recorded his pulse rate as part of his fitness program over time. So a quick check of that Fitbit app showed that the irregular heartbeat was due to the seizure and not a chronic problem. So the doctors were able to go ahead with the procedure and save John's life. So it's a very interesting perspective. Again, if you think back on what Geisinger is doing and some of the reviews there, patients leave digital breadcrumbs everywhere. And so having a secure, well-designed analytics platform can not only give you great insights to your own data silos and your own data structures that might be inconsistent, but most importantly, the mission that we're in, the mission that you're in, most importantly, it can help you save lives, just like John's life was saved last year from his Fitbit, which was, by the way, the first recorded instance of a Fitbit saving a human life. So with that, I appreciate your time. We have time for some questions. I hope you have a few, and we may end up a little bit early, so you might get a little bit of time back. So back to the moderator for Q&A.
All right. Thanks very much, Chris, for a great presentation, very informative, and we do have a few questions. So let's get started. First of all, someone's wondering, whether joint ventures, centers of excellence, a cardiovascular center of excellence, for instance, that may involve two or more healthcare enterprises, do they present any unique challenges in terms of business associate agreements or platforms models? from your perspective?
Well, I'm not a lawyer, but I play one once in a while with other lawyers. So joint ventures really need to decide how they're structured. So if the joint venture has its own new venture, then the business associate agreement would be with that venture, and then of course there would be agreements that underlie how the other covered entities or the organizations support that venture. So that happens a lot in healthcare. If you look at some of the ACA in years past, where accountable care organizations were formed, many times they were done with joint ventures where others would partner in and try to work together, and they would usually create a new entity for that. It's probably a little cleaner than that if you do it that way, rather than everybody share a little piece of the pie in terms of liability. But again, I think that's more of a legal question that would be best answered by somebody who's very well steeped in that topic.
You mentioned a Fitbit towards the end of your presentation, and we had someone wondering, whether it's reasonable to expect that clinicians will use data from Fitbits, or other devices, perhaps, as you call the digital breadcrumbs, so to speak.
Yeah, I think it's silly that we don't as much as we should. We have lots and lots of data about ourselves. We are collecting that for a reason. The old term, if you remember, the quantified self, it was a real movement among those trackers. And so if you're recording your health history on your Apple device or your Fitbit or whatever it is, why isn't the doctor using that to help you treat yourself? And so you're starting to see more and more systems start to embrace that type of an approach. The biggest challenge was integrating those breadcrumbs into the EMR and the EHR. And so you're starting to see a lot more adoption of APIs. There are some leading institutions in the United States that are working on some of that. I can't speak for Kaiser, but I know that they're leading edge in a lot of these types of initiatives of how to use these breadcrumbs in a way that is meaningful. Geisinger is another one, for example. But it's a great question, and by golly, we should be using more of that data as long as the consumer consents for it to be used that way.
Well put. Someone else was wondering, the providers you mentioned, are they FedRamped?
Well, if they're providing, so are the providers FedRAMP certified? Is that what the question is?
That's what it is. I'm not.
Okay. So if you're talking about the cloud providers, for example, Amazon, yes, they have FedRAMP certification. I would have to do a little bit more research on Azure or Google, but you have to imagine, and I'm sure that the other ones are, simply because there's just so much data that the federal government needs help with that I'm assuming they've aligned that way as well.
Mm-hmm. Another question, isn't cloud data an archive rather than real-time data? And if so, how do you use it for worthwhile analytics?
So the question is, I've got 50 million records sitting there in archive. How do I use it for insights to the future? There are solutions in the marketplace that will allow you to access that data in a way that that you can incorporate into your data mining, data analytics platforms. I'm not exactly how they actually do that, but NoSQL types of systems make it a lot easier than having to normalize data from 20, 30 years ago up to today in a way that works in a structured type of environment. So look for those NoSQL type of solutions for that.
Very good. And another comment rather than a question, but maybe you could comment on it yourself. Even though everyone has to comply with HIPAA, they have disparate policies or platform challenges, usability versus privacy issues, et cetera. Do you have any perspective on that?
I'd love to comment about comments. It's a great comment. The perspective I have is that HIPAA is, to your point, a non-prescriptive type of guideline. In other words, it's not a security framework. And so what ClearDATA has done, we recognized this years ago, and we said, okay, we're going to align to the gold standard of what's prescriptive, how to comply with HIPAA, but not only comply with HIPAA, but be secure across many different frameworks that apply directly to healthcare. And so we became HITRUST certified. We sought after that Common Security Framework certification. And if you haven't been through that, it's a very, very deep and meaningful process to help you get your controls and your policies and procedures in place as well. But yeah, I think HITRUST helps to solve a lot of that challenge.
Okay. Well, thank you again, Chris, for a really great presentation, very informative, and thanks to all of you who submitted questions. I think we're just about out of questions right now, and but we would like to thank everyone who joined us today for what we hope you found was a very eventful session and educational session. So please, just a reminder to be sure to complete the evaluation that will be popping up on your screen and share your thoughts with us. And I'd like to thank Chris Bowen once again for taking the time to share his expertise with us. And just a reminder that today's session will be available on demand until July 18th. Thanks again, and have a great day.